Imagine a world before computers. How did humans process complex calculations? Now, let's journey back in time to an era where the word computer was an alien term. The concept of computing didn't begin with the advent of modern computers. In fact, it dates back to ancient civilizations, where the need to calculate complex arithmetic led to the invention of simple tools like counting boards and the abacus. This was the dawn of computing, a time when humans used their ingenuity to solve mathematical problems manually. The abacus, with its beads and rods, was one of the most efficient tools of this era. Originating in Asia, it allowed people to perform arithmetic operations with ease. It was a simple yet powerful tool that laid the foundation for the complex machines that we would see in the future. As we moved into the 17th century, mechanical computing began to take shape. Blaise Pascal, a French mathematician, introduced the Pascaline, a mechanical calculator. This groundbreaking invention could perform addition and subtraction, and with a little manual adjustment, multiplication and division too. It was an extraordinary leap forward in the history of computing. However, the dream of a fully automated calculating machine was still a distant reality. That's when Charles Babbage stepped into the picture. Known as the father of the computer, Babbage conceptualized the analytical engine, a mechanical general-purpose computer. Though it was never built during his lifetime, Babbage's vision set the path for the development of modern computers. The age of mechanical computing was a time of remarkable innovation. It was an era where humans pushed the boundaries of what was possible, paving the way for technological evolution. But this was just the beginning. The age of mechanical computing was just the prelude to an exciting era of technological advancements. Ever wondered how the electronic revolution changed the landscape of computing? As the 20th century dawned, the world of computing was dominated by mechanical devices. These machines, while revolutionary for their time, were limited by their physical components. They were slow, cumbersome, and prone to errors. But a seismic shift was on the horizon, a shift that would forever change the landscape of computing, the birth of the electronic age. In the early part of the 20th century, two key inventions paved the way for the electronic revolution in computing. The first was the vacuum tube, a device that could control electrical current in a sealed environment. This allowed for faster, more reliable computation than mechanical devices could provide. The second was the transistor, a smaller, more efficient alternative to the vacuum tube. The transistor made electronic devices smaller, cheaper, and more reliable, opening the door to a new era of computing. In this electrified environment, two machines stood out as trailblazers of the electronic age. The ENIAC, or Electronic Numerical Integrator and Computer, was the first general-purpose electronic computer. Despite being the size of a room and consuming as much electricity as a small town, the ENIAC was a marvel of its time, capable of performing thousands of calculations per second. Not long after the ENIAC, the UNIVAC, or Universal Automatic Computer, was introduced. The UNIVAC was the first commercially available computer, marking a significant step in making computing technology accessible to businesses and the public. With these machines, the transition from mechanical to electronic computing was complete. As the electronic age dawned, the world of computing was forever transformed. The speed, efficiency, and reliability of electronic devices made complex calculations and data processing not only possible, but commonplace. The once slow and cumbersome world of mechanical computing was left in the dust as the electronic revolution ushered in an era of rapid technological advancement. As electronic computing took the world by storm, the stage was set for the digital revolution. What sparked the digital revolution? How did it reshape the face of computing? These are questions that have intrigued many, and today we delve into the answers. In the mid-20th century, the world of technology underwent a seismic shift. An era of digital computing dawned, forever changing the trajectory of human advancement. Pioneers in the field began to harness the power of binary code, zeros and ones, to instruct machines, marking the departure from analog and mechanical systems. The heart of this revolution was the development of microprocessors. These tiny but mighty components are the brains behind every digital device we use today. In the late 1960s, companies like Intel and Motorola began to perfect the art of cramming thousands, then millions, and now billions of transistors onto a single silicon chip. These chips were capable of processing data at unprecedented speeds, revolutionizing the way we interact with technology. This revolution didn't stop at large corporations or research labs. The advent of microprocessors paved the way for the creation of the first personal computers. In the mid-70s, companies like Apple and Microsoft were born. They recognized the potential of these powerful chips and began to build computers that were smaller, more affordable, and user-friendly. The early personal computers were nothing like the sleek devices we're familiar with today. They were often large, clunky, and required a certain level of technical expertise to operate. However, they were a significant leap forward from the room-sized behemoths of the past. For the first time, individuals could have the power of computing in their own homes and offices. This period of rapid technological advancement didn't just change the way we use technology, it fundamentally changed our relationship with it. Computing was no longer a specialized field, confined to the labs of scientists and engineers. It became a part of everyday life. Anyone could own a computer, write software, and shape the digital world. The digital revolution democratized computing, bringing it into homes and offices worldwide. It was a time of innovation and transformation, a time that set the stage for the technological marvels we enjoy today. Can you envision a world without the internet? What role did it play in the evolution of computing? Imagine, if you will, a vast interconnected web of information, a means of communication transcending geographical boundaries, a tool that would forever change the landscape of computing. This is the internet. The birth of the internet was a pivotal moment in the history of computing, a time when the digital world truly became global. The seeds of the internet were sown in the late 1960s with the creation of ARPANET, a project funded by the U.S. Department of Defense. This was the first network to implement the protocol suite TCP/IP, the foundational building blocks of the modern internet. ARPANET started with just 4 nodes but rapidly expanded, demonstrating the potential of a network where any computer could communicate with any other, regardless of the physical distance between them. But the internet as we know it today truly took shape in the early 90s with the creation of the World Wide Web by British computer scientist Tim Berners-Lee. The web provided a user-friendly interface to navigate the vast resources of the internet. Suddenly, information was at our fingertips, and the world became a smaller place. The internet revolutionized computing in ways that are still unfolding. It transformed computers from isolated machines into portals to a worldwide network of information, fundamentally changing how we interact with technology and with each other. It made information accessible and shareable, allowing for the creation of new types of software and services, from email to e-commerce, from social media to streaming video. The internet also democratized computing, breaking down barriers and opening up the world of technology to anyone with a connection. It's hard to overstate the impact of this global network on our lives and societies. It has shaped our culture, our economies, and our personal lives in profound ways. It has made the world smaller and more interconnected, and it has set the stage for the next big leap in computing. The internet era connected the world, leading to the next big leap in computing, the mobile revolution. How did the shift to mobile computing change our interaction with technology? Just as the dawn of the digital age reshaped the landscape of computing, the mobile revolution ushered in a new era that would once again redefine our relationship with technology. Imagine a time before smartphones and tablets. Computing was largely confined to desktops and bulky laptops. Then came the first wave of mobile devices, altering the course of technology forever. Suddenly, computing wasn't just something we did at a desk. It moved with us, adapting to our on-the-go lifestyles. The introduction of smartphones and tablets wasn't just about new gadgets, it was a paradigm shift. These devices, equipped with touch interfaces, invited us to interact with technology in a more tactile and intuitive way. No longer did we need to master complex commands or navigate through endless menus. Instead, we could swipe, pinch, or tap our way through digital worlds. And let's not forget about the mobile applications, or apps, as we fondly call them. These tiny software programs transformed our mobile devices into versatile tools. Want to check the weather? There's an app for that. Looking for a new recipe? There's an app for that too. From gaming and social networking to health tracking and online banking, apps turned our smartphones into digital Swiss Army knives, capable of performing a multitude of tasks. But the mobile revolution was not just about convenience. It also democratized technology, making it more accessible to people of all ages and backgrounds. Children could use educational apps to learn, while older adults found smartphones an easy way to stay connected with family and friends. The mobile revolution didn't just make computing portable, it made it personal. Our devices became extensions of ourselves, holding our photos, messages, and memories. They became our primary source of information, entertainment, communication, and so much more. The mobile revolution made computing portable, setting the stage for the current era of cloud computing. As we step into the future, we can only imagine how this journey of technological evolution will continue to unfold. What is cloud computing and how has it changed the way we access and store information? In its simplest form, cloud computing is the delivery of computing services over the internet, a shift from the traditional way of having local servers or personal devices handle applications. It's like having a virtual cloud that can perform all the functions of a normal computer, but with the added benefit of being accessible from anywhere, at any time. The impact of cloud computing on the computing landscape has been profound. It has revolutionized the way businesses operate, providing them with an opportunity to cut costs, increase efficiency, and streamline operations. One of the key developments in the cloud computing era has been the rise of the SaaS, PaaS, and IaaS models. Let's break those down. Software as a service, or SaaS, has changed the software market dramatically. Instead of purchasing software to install or additional hardware to support it, users can now access software applications over the internet. Think of your favorite email service or photo sharing app. Platform as a service, or PaaS, is another layer up. It provides a platform on which software can be developed and deployed. This means developers don't have to worry about underlying infrastructure, operating systems, or software updates. They can focus solely on creating the applications. Infrastructure as a service, or IaaS, is the most flexible cloud computing model. It provides instant computing infrastructure, provisioned and managed over the internet. It's like having an entire data center available at your fingertips without the costs and complexities of managing it in-house. Cloud computing is not just a technological shift, but also a mindset shift. It's about embracing flexibility, scalability, and efficiency. It's about understanding that data and applications don't have to be tied to a specific location or device. They can be available whenever and wherever they're needed. Cloud computing has made data and services accessible anywhere, anytime. This is more than a simple convenience. It's a fundamental shift in how we think about and interact with technology, reshaping the future of the computing landscape. What does the future hold for computing technologies? As we look towards the horizon of computing, we find ourselves on the precipice of truly transformative technological leaps. One such leap is quantum computing, an area of study that's been gaining momentum. Unlike traditional computers that use bits, ones and zeros, to process information, quantum computers employ quantum bits or qubits, which can be both 1 and 0 at the same time. This superposition, as it's called, grants quantum computers the potential to process vast amounts of data exponentially faster than their classical counterparts. But the quantum realm isn't the only frontier we're exploring. Artificial intelligence, or AI, is another thrilling avenue. AI isn't just about creating machines that think like humans. It's about developing systems that can learn, reason, and act in ways that enhance human abilities. From predicting weather patterns to diagnosing diseases, AI promises to revolutionize numerous sectors. And speaking of learning, let's not forget machine learning, a subset of AI. Machine learning algorithms enable computers to learn from and make decisions or predictions based on data. Imagine a future where your computer not only stores your favorite songs, but also predicts what you'd like to listen to next based on your listening habits. Yet, these advancements are not without their challenges. Quantum computing, for instance, requires extremely low temperatures to function, and AI and machine learning raise important ethical and privacy questions. But as with any technological evolution, we'll continue to learn, adapt, and find solutions to these challenges. Indeed, the future of computing is not a destination, but a journey. It's an ongoing process of discovery, innovation, and adaptation. And as we continue this voyage, we'll keep pushing the boundaries of what technology can do. We'll keep dreaming and building, creating, and innovating, because that's what we do. That's who we are. The future of computing holds exciting possibilities as we continue to push the boundaries of what technology can do. How have we journeyed from the abacus to AI? This question has been the guiding star of our exploration today, illuminating the intricate pathways of the evolution of computing technology. We started our journey at the dawn of computing with the humble abacus. This simple counting tool, thousands of years old, was the first step in the long road to the powerful machines we use today. It taught us the fundamental principle of computing, the ability to perform calculations quickly and accurately. Our exploration then took us to the birth of the electronic age, where we witnessed the transformation of computing from mechanical devices to electronic machines. This era introduced us to the concept of binary code, the language of zeros and ones, which would become the foundation for all future computing technologies. Then came the digital revolution, a significant leap forward that made computers accessible to the masses. Personal computers became household items, revolutionizing the way we work, play, and communicate. The internet era was a game changer, connecting people and computers across the globe. It brought about a massive explosion of information, making knowledge accessible to everyone, everywhere. Then came the mobile revolution. This era shrunk computers to fit in our pockets, making them portable and personal. We saw the birth of smartphones, tablets, and wearables, and the rise of apps that have transformed our lives in countless ways. Next, we delved into the realm of cloud computing. This era moved data and applications from personal devices to powerful servers, making computing more scalable, flexible, and cost-effective. And finally, we peered into the future of computing. We glimpsed at the potential of AI, quantum computing, and other emerging technologies, offering a tantalizing glimpse of what's to come. The evolution of computing technology is a testament to human innovation and creativity, and the journey is far from over. As we stand on the cusp of unimaginable new possibilities, we can only wonder, what's next in this grand technological odyssey?